our next speaker, which is also the last speaker of today's main track, is Ivy Cecile. You might know her from the weekly Bevy merge train. She writes that, and also she's a technical project manager for Bevy, and she also founded Leafwing Studios with our other speaker, Rose Peck. And yeah, give it up for Alice.
Hi, everybody. I'm Alice, and these days, my full-time job is to make Bevy, which is beyond exciting. Bevy, if you haven't heard of it, is I would describe it as a next-generation open-source game engine made in Rust. Okay, there we go. So before I begin, I'm giving this talk, and you might think that this was all my work. This was oh, Alice is a solitary genius who slaved away and invented this, but that's really not true. This, like pretty much everything that we do at Bevy, was a group effort. I'm just here on the stage telling our story. So this idea of immutable components was something that has been independently requested and independently reinvented by a huge number of just random users, people like you, who was like, hey, wouldn't it be neat if we could do this thing? But I tracked it down and I tried to capture kind of the timeline of what happened. So way back in 2021, back when I was first getting involved with Bevy and when I was, first learning to program, first learning to write Rust, I got really annoyed about how hard it was to use indexes in Bevy. Something like you have a quad tree and you want to track where your positions are, and then you want to quickly look it up. And if you've ever used indexes before in a relational database or anything, you know that keeping them up to sync is a pain in the ass. And I went through a half dozen different solutions, and I walked away very unsatisfied with how hard it is to keep these things synchronized. A couple months later, I was talking with Boxy, who you guys may also know as now a Rust project contributor. She was talking, and they idly proposed that you could use the component trait, and you could just set a constant Boolean or whatever to control whether or not a component was immutable. There wasn't like a lot of thought about like this would be cool for X and Y reasons, but like, hey, you could do that. So in 2023, we stole a really cool feature from one of our main competitors and beloved colleague, Flex, which is a C and C++ ECS. And that was component lifecycle hooks, which we'll talk about later because they become very relevant. In 2024, another contributor, Naked Edible, explained how you could use the immutable components and hooks together to keep our entity hierarchy consistent, because we had constant issues with this getting out of sync, and then this causing undefined behavior because we were relying on the assumption that it was correct in order to make things faster, as one does in game dev. And that to me was like kind of the core moment for this pattern. That's the heart of this design. Shortly afterwards, I came to the realization one day as I was reading a Discord of, oh my god, this solves the indexing problem. And not long after that, one of our contributors, Bushrat, down in Tasmania, said, hey, I'm going to actually go and implement this feature. And it was fantastic, and it went actually quite smoothly. In January of this year, Kurt came down from his cave and took a look at what we had made and said, oh, wow, this is really cool. And then we wrote a relations implementation using it, which was long overdue and very, very much appreciated. And finally here in May, I'm here on stage talking to you guys about it. So what I'm here to do today is basically to share a fun story with you. Most of you guys don't use Bevy. Most of you guys, well, I mean, maybe who here uses Bevy? Let me see. Okay, so maybe like half of you guys use Bevy. I take it back. Thank you guys for coming, and next time I give a talk, I want to see every hand in that audience raised. But why I'm here today isn't to talk about this feature necessarily. It's to share a fun story with you and to talk about how we had this niche feature and it had a stupid bug, and that bug turned out to be actually really useful, so we didn't fix it. And there's a couple of broader lessons about programming and more important patterns, but mostly you're here to hear a fun story because I love this. So that feature that we're talking about that had this bug that turned into a feature is immutable components. This idea that you could somehow prevent users from mutating data while it's inside of the ECS. You say, no, you can look, but you can't touch, which is a very rusty idea. So if you've never used an ECS before, if you've never used Bevy before, let's give you a quick rundown of how things work, and I'll tell you some pretty little lies about what an ECS is and how they work. So all of the data in Bevy is stored inside of the ECS. The ECS and the world is basically a columnar data store. It's not actually a columnar data store, but you can think of it like a spreadsheet. And the entity that things are associated with is their row. It's their unique identifier, and the components are like columns. And then you have systems which run periodically, or whenever you tell them to, saying please read from these columns and select from, filter, join, whatever, and then update the values as I tell you to using normal Rust code. And for the purpose of this talk, the component part is the most important thing to focus on. If you have data of any type that implements the component trait, you can store it inside of the ECS, and each component is stored on a specific entity. Then once you have it in the world, you can query it and you can access it and you can mutate it in whatever way you so please. So if we have a little code example here, you start off by defining a life component. You create a world. You spawn an entity. You insert the component onto that entity, and then you can actually access that component for that specific entity, and you mutate it and read it, and you do things like assertions. Very, very straightforward, except for the fact that it's all type erased. So when you're programming, it's really common to want to carefully control how things are accessed, and the most common way to do that is with the getter setter pattern, where you say, okay, we have some struct. The struct itself is public. Its fields are private, and then you have public accessors and setters, right? And you say, okay, you can read however you want, but when you set it, we're going to go and check that some things are correct, or we're going to correct them for you, and therefore make sure that the invariants, the internal rules for your data, don't get screwed up, which is very nice for programming at scale and avoiding bugs. Immutable components were kind of inspired by that same impulse of what if we could restrict what people were doing in order to avoid these sort of stupid mistakes and to make our APIs more misuse resistant. It's a reasonable enough little request. You go and you make an ECS flavored variant of the getter setter pattern, and where you kind of tie into Rust memory model around the biochecker and the distinction between immutable and immutable access, and everything is lovely. It's not earth shattering, but it's sure, we may as well, I guess. So to understand kind of how you might implement that, let's take a look at a only slightly simplified version of our component trait. So we have send plus sync plus static. You guys love it. The send plus sync plus static bounds, and it's send and sync, so you can send the data across threads, and it's static, so then you can get the type ID out. And it's just a trait, and you just implement it. Very, very easy. We have a derive macro to make this even easier. And then when you're calling get mute on it, you have a C to component bound, so then you can only get components out, so then you know how to access them properly, and so on. But if we take a look at how it might change, we can see that it gets a little fancier, but it's really not too bad. So you now have an associated type. We love associated types over in Bevy. Associated type mutability, and anything that fulfills this must implement the component mutability trait, which in Bevy is a sealed trait. You have mutable and immutable. You get to pick one. Then we implement it, and then all that changes is during the trait bound, during the get mute signature, we restrict it to mutability equals mutable. And so if mutability is not mutable, you can't call get mute on it. Ta-da! It's really very simple. And so you see this code where we have this little annotation that says component immutable. That says, hey, please set that associated type to immutable. And then we try to write the code and we call get mute, and it fails to compile. And we get a lovely error message of type mismatch and where they expected mutable found immutable. And it's like, that's just the error message out of the box. Very, very lovely, very straightforward. We've done this in a type safe way. But it comes with a problem. The problem is, well, yes, you can't restrict people from mutating it while it's inside of the ECS. They can just take the data out of the ECS and then mutate it and then put it back in. And that's really not very immutable, you know? Or they could just insert and overwrite a new value, and I mean, you're technically not mutating the same data, but you may as well be. This seems like it could be a problem, right? Like that just kind of shoots a hole in the feature. We're offering these guarantees, these promises to the user, and saying, I mean, it's kind of immutable, but not really. Like if you wanted to have this, if you want to restrict mutability, you might say, okay, let's go and make sure that you don't have any public setters. Make sure, and you're like, okay, no, you have to prevent overwriting, so you can't have any public constructors either. And you're like, oh, okay, no, I'm totally safe now. And then somebody tells you about mem swap, and then you're like, well, fuck. But rather than trying to fix those holes, because as far as I could tell, they're basically unfixable. Maybe this is actually a feature. Maybe this bug that we can't fix is a feature, and so we should proceed with this feature with immutable components anyways. But kind of in order to understand how it might be a feature, we should talk about lifecycle hooks. So lifecycle hooks are things that trigger when your components, when something happens to your components, when they're added, when they're removed, and so on. And these, the really important thing is this can cause arbitrary side effects. It has a ref mute world, it goes and it mutates the world immediately in any way that you want in order to do this. And these are designed as kind of like constructors and destructors. They're designed to enforce invariants. And the really cool thing here is when you're using that bug, that immutable components loophole, I guess I'll call it, is whenever you do this, you're inserting and then removing. And that means you are always, when you do it, triggering these lifecycle hooks. And that means you have arbitrary reactions that trigger immediately every time. And that is very, very, very powerful for maintaining invariants. As a bit of an aside, if you've used Bevy, you're like, man, this sounds a lot like change detection. We have this whole feature that we've had since, Bevy 0.3 that I helped design, where you can say, hey, what's changed, and then respond to changes. Why can't we just use change detection? So in order to understand the answer to that, we should take a look at how change detection is implemented. So the basic idea here is we have a mute_t smart pointer type, okay? And it dereferences to t, and whenever you have, whenever you change something, the tick inside of it updates, and it says, okay, this is the last time I was changed. And whenever you run a system, it says, this is the last time I was run. And then you compare the change tick to the last time the system ran, and then you say, okay, is this newer or older? And that's great. It's quite efficient. It's very straightforward, and it's very reliable. But the problem here is that it doesn't catch everything. It doesn't catch everything immediately. So the question here is, why do we need both? Why do we want to have both change detection and this immutable components loophole? Why isn't, like, the immutable components loophole allows us to respond to anything arbitrarily immediately, like way, way, way less room for bugs. The problem here is that it's really slow. there are two ways that that it's really slow. The first one is that Bevy is fundamentally multi-threaded. Bevy allows you to run multiple systems in parallel simultaneously, each of which are accessing a different part of the world by splitting the borrow. And if you allow them, any arbitrary system, to provide arbitrary side effects that can access any part of the world that it didn't declare access to, you're going to run into problems. And so in an ECS where you didn't do that, you could theoretically do this, but you still wouldn't want to. The core problem here is that there are two different mechanisms to do this sort of events. There are pull-based mechanisms, like change detection, where you're polling for events and asking, do you have anything new for me? Is there anything that I need to do? And there are push-based mechanisms, like immutable components, where you trigger something and then it propagates downstream and downstream and downstream and downstream until it stops echoing. And each of these have their trade-off. The pull-based mechanisms are much more efficient because you can batch them. And this is one of the core principles of ECS. It's one of the core principles of data-oriented programming. It's one of the core principles of writing code that's fast. Is you need to do similar things together, so then you get better memory locality, and because then you can take a more global view, because then you can use parallelism, all of these things. But pull-based mechanisms have. You have to constantly pull. You say, hey, is there anything for me to do? Is there anything for me to do? And they also take delayed effect, which is a huge problem because it introduces this gap between action and reaction, and in that gap, bugs sneak in. The push-based mechanisms will have higher overhead, but they'll have immediate effect. They won't require any polling, and they are very, very good at leading to arbitrary spaghetti, because you're like, hey, when this thing happens, you should do this other thing. And then when this thing happens, you should do this other thing. And it just kind of fragments through your code, which is hard for debugging. So, but as a result, there are times where you might want one, and there are times where you might want the other. And so both of these mechanisms should exist in Bevy. But that notion of closing that gap where the bugs can squeeze in is really, really important, and that's why this immutable component loophole is a big deal. That's why it's so useful. That's why we managed to implement relations with it, because relations, for those of you who don't know, are basically a structure. It's a doubly linked list stored in the ECS where you have one entity with a component that points to another entity, and then the child entity or so on points back up to its parent, and you can traverse it up and down and so on. And if this gets out of sync, it's very, very horrible. Even if it gets out of sync for a fraction of a frame, you get horrendous bugs, and then you can't. And because you don't have any guarantees here, you can't make unsafe assumptions to make things faster. The other thing you can do is you can use it to implement indexes, which are basically a centralized data store that allow you to say, okay, these components have these values, please look them up quickly. And you can do this to solve that data synchronization problem that I was so upset about way back in 2021. So what's the takeaway here? If you're not using Bevy and you're like, well, that's kind of neat. Like, why did you come to this talk? But also, like, what can you learn and apply to your own programs? So the first one is that push and pull architectures are very different, and they have very different sets of trade-off. And sometimes you want both simultaneously. And when you're thinking about like, how should I respond to events? How should I handle changes? You should think about, do I want this to be push-based or do I want this to be pull-based? And both of them are valuable, but they have different trade-offs. The second one is that try and put flexible side effect systems in places, like where you can just do arbitrary things like as a side effect of when stuff changes or when events occur or so on. It's really, really useful as a powerful tool, but warn your users to use them sparingly because they're slow and confusing. And I think that the rustiest lesson, and the reason why I chose this talk for this venue, is that sometimes by telling people no, by saying, you can't do that because that's not safe, you can get all sorts of powerful new abilities. Thank you.
All right, thanks, Alice, for this wonderful talk. As you can see on the slides, donate to Bevy. if you are a Bevy user, support the ecosystem. It's very important. And now we have some time for questions. Yeah, there was one. Oh. Guess he was just stretching. I think, yeah, there's one here, but I have one already.
Yes.
So, like, what, like, from you have a game studio now, like, what is that about?
So Rose and I, we used to have a game studio back when we were more unemployed, and we're like, hey, let's make some video games, and maybe we'll even make some money out of it, and then. We got mostly too employed, but every now and then we're like, maybe we should make video games. Maybe we should sell video games. So right now, and I spent a while working as an indie dev on a Bevy project for a completely different funded studio, and that was a lot of fun. But right now, in case you didn't know, making video games is not a very good way to make money, and you need money to survive. So right now, I have turned into an engine developer. Maybe one day I'll go back to do game dev again, because I really love project management, I really love programming, and I really love game design, and that's something I miss.
And a bit of a follow-up question. Yours is next, but I'm curious. So, what do you think about Tiny Glade?
So
they use parts of Bevy, but can you talk about it a bit?
Yeah. So Tiny Glade is a really, really cool project and a really beautiful toy. If you guys haven't seen it, it's so cool, and it's incredibly cool that it's written in Rust. It's using a lot of Bevy. They have their own renderer, but they're using the ECS, they're using the input, they're using the windowing, and so on. And then they manage to. So, when you tell people who aren't game devs, oh yeah, they're not using Bevy's renderer, they're like, okay, so it's not like really using Bevy. Like the Bevy must kind of suck. But if you talk to professional game devs about this, they're like, holy shit, you can replace the renderer? But it's I'm not being paid by them. I don't even think they've given us any money. But anyways, it's a fantastic game. It's a delightful little toy. If you guys like cozy, charming experiences, do that. It doesn't have a lot of gameplay, so it's not really for me. But I've messed around with it, and it's such a mastery. Like it's a delight of procedural generation and tech art.
Perfect.
So yeah, Bevy is breaking very often. So let's not talk about stabilization, but what's the next thing that will break?
What's the next thing that we break for Bevy? I think that's probably going to be all of rendering again. It's rendering is overdue for a lot of tech debt cleanup, both in terms of reorganization and in terms of dynamic materials and in terms of maybe overhauling the rendering graph, and in terms of swapping over to Weasel, which is an extension of the WGSL shader language. And yeah, they're going to break stuff again. And my job is to make sure that everything keeps working as best as they can, and that they actually write better migration guides this time.
Hi. Flex was mentioned very briefly in the talk. I understand that's a C++ ECS, but I don't know much about it. Do you think this sort of immutable components thing could be applied in other languages, or is it like a Rust specific thing?
So this is super easy to do in other languages. You wouldn't use the same mechanisms, obviously, because you don't have traits, but it's at some pretty much no matter what you're doing, you're going to need some way to declare component metadata like this about, like, okay, how is it stored, and is it immutable or immutable, or all sorts of interesting properties of components. And in Flex, they actually store this on the entity. They have components as entities where they have each component gets an associated entity, and then the metadata for the component is itself a component. And as a result, you can do it like that. And Bevy will use something similar where it'll have actually, Bevy does use something similar where it has a type erased variant of this for our components, which are dynamic Rust. It's where they are. So Bevy has implemented its own type system. We have runtime types in Bevy. In case you guys ever wanted runtime defined types in Rust, it's kind of as a side effect of what we do. But as a result, we need to support this within there, and so we just have a field on that component metadata that says, is this immutable or not? I've talked with the Flex author about this. I'm like, this is a really cool trick. You should implement it. And he's like, I mean, I guess. So we have to prove him that it's in fact extremely useful.
Hi, Alice. So, considering that now we have relations and observers and hooks and all these things, it continuously feels like all the cool features we wished for in the ECS have already been implemented or are already there. And yet, with newer versions of Bevy, the ECS developers still find new things to work on, and they're always surprising new developments in ECS, even though this is the most mature part of Bevy. So, what is ECS Dev up to now, and what are the things coming for the ECS in the future?
Yeah, so ECS devs are a special breed of people who really love arcane type magic and optimization and pie in the sky grand architecture stuff. So they'll never be done. So in terms of the most important ECS work that kind of remains outstanding, I would say that generalizing relations to more general non-tree-like relations is the most important. And I have actually planned for this cycle an overhaul of how observers work. I think that they're kind of confusing in terms of API. I think that they're badly documented. I think that the way that they share the same trait as events is kind of stupid. So some moderately breaking changes there to kind of clean stuff up. But in terms of what are people actively working on, there's a bunch of optimization work under the hood to allow you to support large numbers of archetypes, which can be used for all sorts of cursed things. Like people have an idea to implement indexes by assigning each value a unique set of dynamic components via binary bit encoding, and then you get archetypal filters on that. So that, and simultaneously that work would support fragmenting relations, like Sander has been pushing for years. The other work that I think is really interesting within the ECS is there's been work to take out to change how our parallelism works between systems, because previously our parallelism works by fragmenting on the archetypes. So if you have two entities that have different sets of components, they can be parallelized. But computing this was relatively slow, and Bevy's and we ended up with a lot of overhead relative. We were over parallelizing, and so it wasn't efficient. And so we were broadly considering moving towards fragmenting on the parallelizing based on which columns of data, which components they access, which will be much faster to check without losing a whole lot of important parallelization. And in exchange, we can pre-compute our schedule and do things like thread affinity, do things like profile-guided optimization, and so on, that I have always very, very much wanted to do, because I think that there's a lot of low-hanging fruit there.
All right, I guess that's about all the time that we have for questions. May I say that in the Rust community, Bevy is a very important component. And with that, give it up for Alice.